Hello students, today we are going to discuss some important questions of chemistry. Let's start. So this is the first question. In period 3 of the periodic table, element B is placed to the left of element A. So first we need to arrange the elements according to the periodic table. Element B is placed to the left of element A. So if element B and this one is element A, element B is placed to the left of element A, choose the correct word from the brackets to complete the following statements. So first statement is the element B would have lower or higher metallic character than A. So first you need to know the trend of metallic character across a period from left to right. Across a period from left to right. Metallic character decreases. So if in the periodic table this element B and A, B is placed left to element A, then the metallic character of B is more than A. The question is the element B would have lower or higher metallic character than A. So the answer is higher. Higher metallic character, just B is left to A. So according to the periodic table, metallic character decreases from left to right across a period. That's why it has the higher metallic character than A. Second one is the element A would probably have lesser or higher electron affinity than B. So first we need to know what is electron affinity. Electron affinity, what is electron affinity? This is the amount of energy released when an atom like X accepts electron to form an ion like this. If X is an atom, so accept electron to form an anion. That is the electron affinity. So in this question, the element A would probably have lesser or higher electron affinity than B. So according to the periodic table, B is placed left to A. So B is more metallic than A, and electron affinity, the trend of electron affinity across a period from left to right electron affinity increases. Electron affinity increases from left to right. So in this case, B is placed left to A. That's why the element A would probably have higher electron affinity than B. So this is the answer. Third one, the element A would have greater or smaller atomic size than B. So you need to know the trend of atomic size. Atomic size across a period from left to right, the trend of atomic size is decreases. So if we have this element B which is placed left to A, so atomic size of A is smaller than B. That's because the trend is atomic size, which depends on two factors. So that is decreases from left to right. So in this question, B, just because B is placed left to A, so the atomic size of A is smaller than B. So the answer is this. Next question. Answer the following question based on the table above. So this is the table given. What type of bond is formed between W and Z? So the configuration of W is 281. So this is the configuration of W, which is 281, and X, which is 287. So this is clear that W, it has 1 electron in the outermost shell, and X, it has 7 electrons in the outermost shell. So this is a metal. This one is a non-metal. Now, what type of bond is formed between W and X? So W is a metal and X is a non-metal. So the bond is clearly ionic bond or electrovalent bond. Ionic or electrovalent bond. That's, it is clear from the electronic configuration that W is a metal and X is a non-metal. So metal and a non-metal, there is a transfer of electrons and the bond is electrovalent or ionic. Second one is the Y and Z. So Y, it has 5 electrons in the outermost shell, and Z does. So this is a non-metal, Y, and this is also a non-metal. So it is clear from the given table that this is a non-metal Y and Z is also a non-metal. So the Y and Z, the bond is clearly covalent bond. So covalent bond where sharing. So in the first case, the first question, ionic bond where transfer is there, and second one, covalent sharing. What is the formation? That is the formula of the compound formed between X and Z. So X, it is a non-metal and Z is a non-metal. So the formula of the compound X and Z, that is ZX, and W and X. So this is W, this is a metal, and this is Z. So the, that is W and X. So W is a metal and this is a non-metal. So the bond, the compound is W and X, sorry. So this is W and X. So it is a metal and X is a non-metal. So clearly the bond is electrovalent bond, which is WX. Next question. Arrange the following as per the instruction given below. So first 3 elements are there: helium, argon, neon, increasing order of number of electron shells. So number of electron shells from left to right across a period, number of electron shells remains same, and down the group number of shells increases. So in this question, helium, argon, neon. So you have to place those elements: helium, neon, and argon. So if the number of shells down the group, number of shells increases. So helium, neon, argon. So it has the maximum number of shells in argon. Now the order is increasing order of number of shells. So the answer is just according to the periodic table. This is the arrangement of elements. Down the group, number of shells, down the group, number of shells increases. So maximum in argon, Just because increasing order, you have to arrange those elements like this. Argon maximum, then neon, helium. So number of shells increases down the group. Argon, it has maximum number of shells, and helium minimum. Next question, sodium, lithium, potassium increasing ionization energy. So ionization energy or ionization potential. What is ionization potential or ionization energy? The amount of energy required to remove an electron from isolated gaseous atom. Like if this is an isolated gaseous atom, so if we remove an electron from this, it will be positive charge. The energy required, that is ionization energy. So in this question, we have to arrange those elements, sodium, lithium, potassium, increasing ionization energy. So first you need to arrange those elements according to the periodic table. So sodium, lithium, potassium. So lithium is placed like this, then sodium, and the last one is potassium. This is according to the periodic table. Lithium is first, then sodium, then potassium. So you need to arrange this down the group. Now ionization potential or ionization energy, the trend, like ionization potential from left to right across a period, it has like the left side elements, it has one electron, the outermost shell, like lithium. Then left to right, ionization potential increases. Just the number of electrons increases in the outermost shell. That's why ionization potential increases. Now down the group, ionization potential or ionization energy decreases. So you know the electronic configuration, lithium, sodium, potassium. So lithium is 2 1, this is 2 8 1, this is 2 8 8 1. So the distance is maximum in case of potassium. The distance is maximum, so the outer attraction is minimum in case of potassium. The outermost shell, it is like more easily removed electron in case of potassium. So the ionization potential is minimum in case of potassium and maximum in case of lithium, just because lithium, it has like one electron in the outermost shell and the distance is minimum. Now the trend of ionization potential, that is decreases down the group. So if we need to arrange lithium, sodium and potassium, increasing ionization energy, so that is maximum in case of lithium, then sodium, and then potassium. This is the trend. Third one is fluorine, chlorine, bromine, increasing electronegativity. Now electronegativity, you need to know the trend of electronegativity. Electronegativity, that is the tendency to attract electrons. That is the tendency to attract electrons towards itself when it is a compound like covalent bond. So the tendency which has the more tendency to attract electron, the electronegativity is more in case of that element. So in this question, the elements are fluorine, chlorine and bromine. So if fluorine, chlorine and bromine are arranged like this. Now the trend of electronegativity, that is the right side according to the periodic table, the right side elements, the electronegativity is more, maximum in case of the right side elements like non-metals. The trend from left to right, electronegativity, from left to right, electronegativity across a period increases, and down the group decreases. So in this question, if this is the trend, the electronegativity is maximum. If this is fluorine, chlorine and bromine, the answer is decreases. So maximum in case of fluorine, then chlorine, and lastly bromine. So this is the trend. Last question, sodium, potassium, lithium increasing atomic size. Sodium, potassium, lithium. So sodium, potassium, lithium, sodium, potassium are arranged like this. Now increasing atomic size, the trend of atomic size from left to right, atomic size decreases. Across a period from left to right, atomic size decreases, and down the group, the trend, atomic size increases. So according to the periodic table, lithium is placed, then sodium, and lastly potassium. So increasing atomic size, so atomic size increases down the group, so it is maximum in case of potassium. So the answer is first potassium, then sodium, and lastly lithium. So this is the answer for the last question, fourth question. Next question. Element P has electronic configuration 2881. First you need to check the electronic configuration of element. The number of chlorine atoms present in the chloride of P. So if the electronic configuration of this element, like if this is element P, the outermost shell, it has 1 electron. So this is outermost shell, it has 1 electron, then valency of P, that is 1. And we know the valency of chlorine, if it is like chloride ion, that is -1. The number of chlorine atoms present in the chloride of P. So if according to the electronic configuration of P, it has 1 electron in the outermost shell, and chlorine, the valency of chlorine is 1. So if the compound is formed using P, the element P, and chloride and chlorine, so the number of chlorine atoms present in the chloride of P, that is 1. Just because P, valency of P is 1, and chlorine, it is also 1. So if it is the chloride of P, then we need to add 1 chlorine atom to form the compound using P. So the answer is 1. Next question. Hydrogen is an isotope of, this is the isotope of hydrogen. The modern periodic table, it will be placed before hydrogen, it will be placed after hydrogen, it will be placed at the same position as hydrogen, or not have any position in the periodic table. Now according to the periodic table, that isotopes it has. Now what are isotopes? Isotopes, same atomic number, a different mass number, differ in mass number. If this one is the isotope of hydrogen, it is clear that the hydrogen, it has 1 electron. The atomic number is 1. So it is clear that the place of this isotope in the periodic table, just because isotope has same atomic number but different mass number, so all the isotopes are placed in the same position. So the place be placed at the same position as hydrogen. So if hydrogen is there, all the isotopes of hydrogen are placed in the same position. So the answer is C, third one. Next question. Which of the following electronic configuration represents the most electropositive element? Now, what are electropositive elements? Electropositive elements are those elements which has a tendency to lose electrons. Like if the first one is 2 1, so 2 1, this is electropositive. 2 8 1, this is also an electropositive. 2 2, this is also an electropositive. But the question is, which one is the most electropositive element? So most electropositive, this is not, this one is not, just because 2 electrons in the outermost shell in this 2 1 and 281. The first case is 2 1 and this one is 281. So it has 1 electron in the outermost shell, and second one is it also has 1 electron in the outermost shell. But the answer is 2. Why? Just because the distance in this case, in this one, in this element, the distance is maximum, more than the first one. So it has number of shells 3, it has number of shells 2. So the answer is 281, that is 281. It is more electropositive because the tendency to lose electron in this element is more than the first one. It has also 1 electron, and second, this is also 1. The valency of this is also 1. Both are electropositive elements, but in this case, the distance is more, number of shells more, so it has more tendency to lose electron. That is more electropositive than the first one. So the answer is 2. This one is the most important question, assertion reason type questions. Assertion is alkali metals do not form dipositive ions. Alkali metals, for example, sodium. Sodium, the ion of sodium is Na plus, and potassium, K plus. These are alkali metals. So do not form dipositive ions. That is true. The assertion is true. Reason, after loss of 1 electron, alkali metals achieve stable electronic configuration of noble gas. So if sodium, like sodium, the atomic number of sodium is 11. The configuration is 281. So after losing 1 electron, Na plus is formed, which is the stable electronic configuration like noble gas. So that is also true. The reason is also true. So both A and R are true, and R is the correct explanation of assertion. So if both these statements are true and assertion, reason is also the correct for this assertion. So the answer is 1. The statement is true and this is the correct reason for this statement. So the option 1 is correct. The ratio between the volumes occupied by 4.4 grams of carbon dioxide and 2 grams of hydrogen gas. So you need to add some numericals, just questions. So numericals are also important. This is a question from stoichiometry chapter. The ratio between the volumes occupied by 4.4 grams of carbon dioxide and 2 grams of hydrogen gas. So first you need to know the formula of number of moles. Number of moles given, that is the given mass by molar mass. Most important type of question, like this is number of moles given mass by molar mass. So in this question, the volumes occupied by 4.4 grams of carbon dioxide and 2 grams of hydrogen gas. First, mass of CO2, that is 44. So the number of moles of carbon dioxide according to the formula, that is given mass by molar mass, given mass 4.4 gram, so that is 4.4 divided by the molar mass of carbon dioxide, that is 44. Okay, so the answer is 0.1. Now 2 grams of hydrogen gas, 2 grams of hydrogen gas. So if H2, the mass of hydrogen 2 grams and number of moles, this is given 2 grams of hydrogen gas. So 2 grams given, the mass is also 2, so that is 1. Now the ratio between the volume, so that is also like number of moles, that is the ratio. So in this case, first carbon dioxide, answer is 0.1 number of moles, then hydrogen, that is 1. So this is the ratio. It's clear, the ratio is 1:10. So among these options, option C is correct. Which of the following about oxides is correct? This is another important question. A basic oxide is an oxide of a non-metal. Incorrect. Basic oxides, which statement is correct? So basic oxides are of metallic oxides. Metallic oxides are basic in nature, like Na2O, K2O, like this. So this is correct, incorrect statement. Second one is acidic oxide contain ionic bonds. Acidic oxides are the oxides of non-metallic oxides. Not ionic bond. Non-metallic oxides are not this. So that those are covalent. So this is also incorrect statement. Amphoteric oxides contain a metal. This is correct. The statement is correct just because what are amphoteric oxides? Now amphoteric oxides. Amphoteric like aluminium. Amphoteric oxides. Amphoteric oxides are basically not basic oxides, not acidic oxides. Acidic, not basic. So if acid is there, amphoteric oxides reacts with this kinds of acids to form salt and water. If base is there, amphoteric oxides reacts with those base to form salt and water. So those are not basic oxides, not acidic oxides. Those are amphoteric in nature, like aluminium oxide, zinc oxide, amphoteric oxide. So aluminium, zinc, these are metals. So amphoteric oxides contain a metal. This statement is true, correct one. Basic oxides are always gases, not like that. Basic oxides Na2O, K2O are not always gases. So this is also incorrect one. Next question. A nitrate which forms a precipitate with ammonium hydroxide. So in stoichiometry chapter or analytical chemistry chapter, so precipitates are formed using sodium hydroxide and ammonium hydroxide. Reactions are there, precipitates are there. So a nitrate which forms a precipitate with ammonium hydroxide and is also soluble in excess of it. Ferrous nitrate, incorrect. Ferric nitrate, also incorrect. Lead nitrate, also incorrect. So the correct option is copper nitrate. Copper nitrate. Now you need to know the equation. Copper nitrate reacts with ammonium hydroxide. So this is ammonium hydroxide. That is copper hydroxide, which is pale blue or light blue precipitate plus ammonium nitrate, another compound. So this is the precipitate. This is the precipitate copper hydroxide precipitate. So the answer is copper nitrate. In case of reaction with ammonium hydroxide, copper nitrate with ammonium hydroxide, this is the reaction. Copper hydroxide pale blue precipitate and ammonium nitrate, another compound. The equation below shows the reaction between element X and dilute sulfuric acid. So this is dilute sulfuric acid and another element is X. Which particles are responsible for conducting electricity in dilute sulfuric acid and compound XSO4? Electrons, only positive ions, only negative ions, both positive and negative ions. So if H2SO4, sulfuric acid, dissociates in water, ions like H plus, sulfate. These ions are formed cation and anion if sulfuric acid dissociates. And in this question, according to this equation, XSO4, so if this is XSO4, X is another element in this reaction. So if XSO4 is like this, so the question is which particles are responsible for conducting electricity in dilute sulfuric acid and compound X? Which particles? Positive and negative ions, both positive ions present in this two, sulfuric acid and this compound, and negative ions. So the answer is both positive and negative ions, not only negative or only positive. Next question. Which of the following would weight the least? Now this is the question from stoichiometry chapter. So you have to add some questions like this and answer like questions like this, where you need to calculate the grams, the weight of those elements, like different ways. First one is 2 gram atoms of oxygen. If 1 gram atom of oxygen, that is 16. 1 gram atoms of oxygen is 16. 2 gram atom of oxygen, 16 into 2, 32 gram. So the weight of this 32. 1 mole of sodium. 1 mole of sodium, we know that 1 mole of sodium is 23 grams. So the weight of this is 23 and the first one is 32. 22.4 liters of carbon dioxide. So 22.4 liters volume of carbon dioxide. So carbon dioxide, that is C plus O. (12 plus 2 into 16). 44 gram. 22.4 liters, that is 1 mole, 44 gram. Last one is 6.023 10 to the power 22 atoms of carbon, that is 1 carbon atom, 12 gram. So the question is which one of the following would weight the least? First 32, then 23, this one is 44 and this one is 12. So the least is option D. That is the correct one. Next question. An aqueous solution of copper sulfate turns colorless on electrolysis. Which one of the following could be the electrodes? Electrolysis using copper sulfate. So what is that? This is electrolysis. The arrangement is like this: anode and cathode. An aqueous solution of copper sulfate turns colorless. So this is the aqueous solution of copper sulfate. We have this aqueous solution of copper sulfate turns colorless on electrolysis. So if the color of this solution is colorless, so cathode copper. So firstly, cathode copper, this is not the correct one. cathode is copper, and anode is platinum. So this is only Q. Just because according to this question, the color turns colorless. So if we have this copper cathode and copper anode, that the color is not colorless, just because we need to add platinum anode. Anode is platinum and cathode is copper. So the answer is only Q. Next one. Identify the following terms. So these are the questions, like some definitions are given and you have to answer only one word or two words. A bond formed between two atoms by sharing of a pair of electrons, with both electrons being provided by the same atom. Both electrons provided by the same atom. That is coordinate bond or dative bond. The answer is coordinate or dative bond. So I have to give an example of coordinate bond, the most important example, which has the three different kinds of bonding: ionic, covalent and coordinate. That is ammonium chloride. Ammonium chloride. This is the example of a bonding where ionic, covalent and coordinate bond is present. So the structure is like this: NH4 plus Cl minus. This is NH4Cl. So the first answer is coordinate bond. Second one, a salt formed by the complete neutralization of acid and base. Normal salt. Normal salt. In case of normal salt, no replaceable hydrogen atom is present. If this is acid salt, then one replaceable hydrogen atom present. So no replaceable hydrogen atom, neutralization reaction, that is a normal salt. The answer is normal salt. A reaction in which the hydrogen of an alkane is replaced by a halogen. This is alkane. This structure of methane, where hydrogen of an alkane, so in this, like, hydrogen of methane is replaced by chlorine atom, like this. So this hydrogen atom replaced by this chlorine atom, and we have this structure CH3Cl. Hydrogen is replaced by chlorine. So this is substitution reaction. The name of this reaction is substitution. Alkanes undergo substitution reaction, and where alkanes of, like, hydrogen of an alkane is replaced by halogen, that is substitution reaction. The answer is substitution reaction. Next question. The energy required to remove an electron from a neutral gaseous atom, we have already discussed this topic, that is ionization potential or ionization energy. Two terms you need to remember, that is ionization potential, that is the energy, or ionization energy. Same thing. Ionization energy. Ionization potential or ionization energy, where the energy required to remove an electron from a neutral gaseous atom. So this is, if this atom is like this, after removing one electron, like this, that is the ionization energy. A homogeneous mixture of two or more metals, or a metal and a non-metal in a definite proportion in their molten state, that is alloy. Alloy. different metals and non-metals are used, the answer is alloy. So this are like one word answer type questions are most important for your board exam. Now, one more interesting and important topic of chemistry, that is organic chemistry, and the structural diagram of this kind of IUPAC naming. So these are some IUPAC naming. You have to draw the structures. First one is propanoic acid. So propanoic acid. Prop. First you need to know the root word of this organic compound, that is prop. So 3 number of carbons present in this structure, propanoic acid. So oic acid, that is acid group, C double bond O, OH. So prop, number of carbon 3, acid group, oic acid. So this is the structure, and rest are hydrogen. This is the structure of propanoic acid. Next is pentanol. Pent. Pent. The root word is pent. Pent. The root word is pent. So 5, the number of carbons 5. Pentanol. So if we need to, so the arrangement is like this. First you need to add the number of carbons 5. Then number it. Numbering 1, 2, 3, 4, 5. Pentanol. So all is alcohol. Alcohol group. Alcohol all. So alcohol present in the position 2. Then rest are hydrogen. This is 1. Please correct it. This is the structure of pentanol, where 5 number of carbons 5. Then at the second position of carbon, OH group, that's functional group alcohol present, and the rest are carbon. So the structure is this. This is the structure of pentanol. Next one is 2,2-dibromobutane. Dibromobutane, the root word is butane. 2,2-dibromo. Bute. Number of carbon 4. Then 2,2-dibromo. So bromine is present, the halogen bromine. Dibromo. So if 1, 2, 3, 4, place those bromine at the second number of carbon, that is this bromine, and rest are hydrogen. This is 2,2-dibromobutane. Bromine, 2 bromine atoms present, the second number of carbon, the butane, that is the root word. This is the structure of 2,2-dibromobutane. 2-butanol. 2-butanol. Now, bute is the root word bute. Number of carbons 4. Butanol, that is this 2-butanol. Butanol is the ketone group, functional group ketone. This is the structure of 2-butanol. Methanol. Last one is methanol. Methanol. Methanol, that is aldehyde. Aldehyde group, the functional group is aldehyde. Now methanol, that is number of carbon 1. So I have already drawn the structure 1, number of carbon 1, another one is hydrogen. So this is the structure of methanol. Now you have to add the IUPAC naming of these structures. The question is IUPAC naming. So the first structure is this. First, number of carbon 1, 2, 3. This is the alcohol group, functional group, alcohol is all. 1, 2 and 3, number of carbons 3. So the structure is, the root word is pro. Alcohol is present at the first number of carbon, that is all. So the structure is propanol. Propan 1 all or propanol. This is the structure, IUPAC naming of this first structure. Meth 8 pro. Alcohol present in the first number of carbon, that is all. So propanol is the structure, IUPAC naming. Next one. First, second or double bond is present in this structure. So first you have to number those carbon like this. This is 1, just because double bond is there. 2, 3, 4, 5. So number of carbons 5. So the root word is pent. Double bond is present in the first number of carbon. So that is double bond. If double bond is there, that is alkene in. So the root word is pent. Double bond is present in the first carbon. So the structure, the naming, the IUPAC of this structure is pent 1 in or pentene. This is the IUPAC naming of this structure, just because double bond is present the first number of carbon. Next question. Draw the structural formula and give the IUPAC names of the 2 chain isomers of butane. Now what are isomers? Isomers same molecular formula but differ in structural arrangement. The isomers, 2 chain isomers of butane. Firstly, butane is this. This is the structure of butane. This is the structure of butane. If we have the isomer of butane, so this is C4H10. The molecular formula, this C4H10 butane. Now the another isomer of this butane, this structure butane, that is Same molecular formula but different structural arrangement. Structural formula is different. So this is the isomer of butane. See, this is also C4H10. Same number of carbon and same number of hydrogen, but the arrangement is different. First one is butane or N-butane. Second one is isobutane. Now this is isobutane is not the IUPAC naming of this structure. The IUPAC naming is, this is the methyl group. This is the methyl group CH3. So the numbering is like this. Methyl group is present in the second number of carbon, that is 2-methyl propane. 2 methyl group is present in the second number of carbon, so 2-methyl methyl methane ethane propane. 2-methyl propane. This is the IUPAC naming of this structure. So two isomers of butane is there. First one is butane. This is the general formula of butane, general structure of butane. And isomer is this. The naming is isobutane or 2-methyl propane. 2-methyl propane is the IUPAC name. So the question is structural, draw the structural formula. These are the structural formulas and give the IUPAC name of these two chain structures. So you have to add the IUPAC names only, not the common names. Common names are not the correct exact answer. So the question is IUPAC names and these are the IUPAC naming. Next question. I draw the structural formula and give the IUPAC names of the 3 chain of structural isomers of pentane. So pentane has 3 structural isomers. First one is the general formula of pentane. This is the general formula of pentane. This is the general formula. This is the structure of pentane. General structure. Structural formula of pentane. This is pentane. Pentane. Total 3 chain isomers of pentane. Another isomer is this. We have to arrange those isomers in this manner. The structural formula of the second isomer of pentane is this. The naming is, if the arrangement is like this, numbering, then methyl group is present the second number of carbon and the root word is methane ethane propane butane. So 2-methyl butane. 2-methyl butane is the root word, butane. This is the second isomer of pentane. And another isomer is this. This is the another isomer of pentane. This is the another isomer of pentane, and the IUPAC is if 3, then 2 methyl group is present in the second number of carbon, and 2 methyl group, this one is a methyl group and this one is also a methyl group. So the second position 2 comma 2, just because 2 methyl groups are there, then 2 methyl groups dimethyl, and the root word is methane, ethane, propane. This is the third isomer, third chain isomers of pentane. Then first one is pentane, the general structural formula of pentane. Second one is 2-methyl-butane, this is the second isomer, and third one is 2,2-dimethyl-propane. Next question. The electron affinity of an element X is greater than, another important type of questions for your exam. The electron affinity of an element X is greater than that of element Y. Electron affinity of an element X is greater than Y. So if we arrange these two elements X and Y, electron affinity of element X is greater than Y. So left to right, the trend of electron affinity. So what is electron affinity? Electron affinity is the energy released when an atom, isolated atom, a neutral atom, gain electron to form an ion. That is the electron affinity. Now element X is greater than that of Y. So electron affinity from left to right increases. We know electron affinity, the trend of electron affinity, left to right electron affinity increases. So if the electron affinity of X is greater than that of Y, so it is clear that X is in the right hand side and Y is in the left hand side according to the periodic table. This is the trend. This is the position of these two elements. Just because electron affinity of element X is greater than Y. So right hand side is X and left hand side is Y. X is placed right to Y. First question is, how is the oxidizing power of X likely to compare with that of Y? So oxidizing power, when the electron affinity is more in case of an element from the other one, so oxidizing power of that element is more. So the answer is X greater than Y. Oxidizing power of X is more than Y. Second one is, how is the electronegativity of X is likely to compare that of Y? Now it is clear that X is placed right to Y in the periodic table just because electron affinity of X is more. So electronegativity left to right, electronegativity increases, the trend of electronegativity increases from left to right. So electronegativity of X is more than Y. The question is, how is electronegativity of X likely to compare Y? Then X is more electronegative than Y. First you need to place those elements according to the periodic table, then answer the questions. Third question, state whether X is likely to be placed the left or to the right of Y in the periodic table. So it is also clear from the first statement, that is X is placed right to Y. This is the answer. Next question. Pratik heated 11.2 grams of element M with 4.8 grams of element N. This is one numerical type of questions from stoichiometry chapter. This is most important part. 11.2 grams of element M, the atomic weight of element M is 56. 4.8 grams of element N to form a compound. Find the empirical formula. Empirical formula are the simplest ratio, the whole number ratios of the atoms in a compound. Those are empirical formula. So 11.2 grams of element M, the atomic weight of that element M is 56. Now firstly, given mass by molar mass, there is M, and N, the given mass is 4.8 and molar mass or atomic weight of this element is 16, just because this are atom, like M is an atom. So given mass of that atom divided by the atomic weight. This is the gram per mole. The first is, if we calculate this number, this is 0.2, and if we calculate this number, then it would be 0.3. So this, the given portion is 11.2 grams of M, 4.8 grams of N to form a compound. So we have this part of M and this part of N. Find the empirical formula of the compound obtained by this 2. So M by N, that is 0.2 for M, element M, and for element N, that is 0.3. So if we have the ratio, just because empirical formulas are the whole numbers ratio, so we need to convert this decimal to a whole number. So that is 2 by 3. So the formula, the empirical formula of the compound is M2N3. This is the empirical formula of the compound. Next question. Give balance equation to each of the following. Action of warm water to aluminium nitrate. Action of warm water, aluminium nitride. Aluminium nitride is this. Action of warm water, aluminium hydroxide, ammonia. Now you have to balance those equations. 3, 3, 6. This is warm water. Warm water. Oxidation of carbon with concentrated nitric acid. Oxidation of carbon with concentrated nitric acid. So this one is concentrated nitric acid. Now balance these equations, like carbon 1, 4 hydrogen, 4 hydrogen, 4 nitrogen, 4 nitrogen, 12 oxygen, 12 oxygen. Okay, balance equation. This is the second question. Third question, laboratory preparation of ethanol by using chloroethane and aqueous sodium hydroxide. Chloroethane, this is chloroethane, and aqueous sodium hydroxide. Aqueous solution of sodium hydroxide. The products are alcohol, ethyl alcohol plus sodium chloride. This is the reaction when alkyl halide with alkali solution gives alcohol and sodium chloride. This is the third equation. I think it is balanced, already balanced one. Okay. Next one. Variety of household fuel is a mixture. This is another stoichiometry question from mole concept chapter. One variety of household fuel is a mixture of propane 60% and butane 40%. So 60% propane and 40% butane. Find the total volume of carbon dioxide added to the atmosphere. The combination reactions are presented. Now the total mixture, that is 20 liters. If propane is 60% and 40% butane, then what should be the volume of that mixture? And 60% propane and 40% butane. First, you need to calculate the volume present in 20 liters of that mixture. So if 20 liters is the total mixture, then mixture of propane is 60%. So 60% of 20 liters, that is 12 liters, and the rest is 20 minus 12, 8 liters. Now the question according to the equation, that is C3H8 plus 5O2. So if we have to calculate the volumes, then the volume of this, so this is propane, 1 volume propane, 5 volume of oxygen, 3 volume of carbon dioxide, and this is not needed. Third one is when butane is there. So butane is 2 C4H10, that is 2 volume, 13 volume, and this one is 8 volume. So you need to calculate the volume of carbon dioxide added to the atmosphere. So if 60% propane is there, that is 12 liters. So from 1 volume of propane, we have 3 volumes of carbon dioxide. 1 volume of propane, 3 volumes of carbon dioxide. If 60% propane is present in the mixture, that is 12 liters. 60%, we have already calculated the 12 liters. So 12 liters of propane, that is 3 into 12, 36 liters. And butane is 40%. So butane, according to this equation, first the given, according to the question or the given equation, that is 2 volume of butane and 8 volume of carbon dioxide. So from 2 volume of butane, we have 8 volume of carbon dioxide. If 40% butane is there, that is 8 liters of butane. If 8 liters of butane is present, then the answer is simple unitary method, 32 liters. So this is from 60% propane, that is 12 liters of propane in the mixture, and 40% butane, that is 8 liters of butane in the mixture. So that is the first, from this propane we have 36 liters, and from butane we have 32 liters. So the question is what should be the total volume of carbon dioxide, that is 36 plus 32. Total volume of carbon dioxide, that is 36 plus 32, 68 liters. So 68 liters is the answer. Next. This one is another important question from stoichiometry chapter. 8.2 grams of calcium nitrate. So two types of questions are there. First one is mass volume combination or only volume combination. So this is the question where we have to calculate the volume of nitrogen. This is the equation given. Volume of nitrogen dioxide obtained at STP. So first question is the volume of nitrogen dioxide, and the second one is mass of calcium oxide formed. So this is the mass. Now you have to calculate the molecular weight of these compounds. Firstly, calcium nitrate. So calcium nitrate is calcium given 40 plus, this is 14. So 14 into 2 plus 3 into 16 into 2, this into 2, that is 2 plus 40, 28, 16. So after calculating this, it would be 328 grams. Then calcium oxide, calcium is 40, oxygen is 16. So 40 plus 16 into 2, that is 2 into 112 grams. You don't need to calculate the molecular weight of nitrogen dioxide, just because volume of nitrogen dioxide obtained. So first question is volume of nitrogen dioxide obtained. So according to this equation, from 320 grams of calcium nitrate, we have this volume. This is 4 volume. So 4 volume is 4 into 22.4 liters. 1 mole of nitrogen dioxide, that is 22.4 liters, the volume of 1 mole of nitrogen dioxide. If it is 4 mole of nitrogen dioxide, 4 into 22.4. From 328 grams of calcium nitrate, we have 4 into 22.4 liters of nitrogen dioxide. From 328 grams of calcium nitrate liberates 4 into 22.4 liters of nitrogen dioxide. Now the question is volume of nitrogen dioxide obtained at STP. So according to this equation, we have 328 from 328 grams of calcium nitrate, 4 into 22.4 liters of nitrogen dioxide. But according to this question given, that is 8.2 grams of calcium nitrate is decomposed. Not whole of this calcium nitrate is decomposed. Only 8.2 grams of calcium nitrate is decomposed. So if 8.2 grams of calcium nitrate is decomposed, then simple unitary method calculation. You calculate this, you will get 2.24 liters of nitrogen dioxide. 2.24 liters of nitrogen dioxide obtained at STP. Then mass of calcium oxide formed. So from 328 grams of calcium nitrate, we have 2 into 50, 112. From 328 grams of calcium nitrate, we have 112 grams of calcium oxide formed, then according to this question, that is 8.2 grams of calcium nitrate is decomposed. So if 8.2 grams of calcium nitrate is decomposed, then what should be the answer? Again, calculate. Fourteen by 5, that is 2.8. The mass is 2.8 gram. This is the answer. So from the first question, volume of nitrogen dioxide obtained, that is 2.24 liters, and mass of calcium oxide formed, that is 2.8 gram. This is the mass. So this kind of questions are there in your paper. Mass volume combined questions. Next is draw the electron dot diagram of ammonium ion. So to draw this ammonium ion, electron dot diagram of ammonium ion, firstly, this is the question from chemical bonding. First, draw the structure of ammonia. First, you need to draw the structure of ammonia, that is this. Please mention the lone pairs. Draw the lone pairs also. This is the structure of ammonia, and write down the name, that is ammonia molecule. Ammonium ion, so plus hydrogen, this is hydrogen ion, hydrogen ion. After this we have ammonium ion like this, ammonium ion, like this, or bond and give an arrow to it towards hydrogen. This is ammonium ion, and this H plus is from water molecule, so plus OH minus. This is ammonium ion, the structure, electron dot diagram of ammonium ion. Give balanced equation for the following. Laboratory preparation of ethine from calcium carbide. This one is another important question from organic chemistry. So lab preparation of ethine from calcium carbide. Calcium carbide is this. Then water. We have ethine, that is acetylene, plus calcium hydroxide. This is the need to balance it to this. Okay, this is the balance equation. Conversion of acetic acid to ethyl acetate. So ethyl acetate, this is the most important topic, most important question, this one. So acetic acid to ethyl acetate. Acetic acid is this, plus ethyl alcohol. When ethyl alcohol combines with acetic acid, it gives the most important product, that is ethyl acetate or ester. Ester. This is ethyl acetate or ester plus water. One second. Plus water. This one is ester. The reaction is called esterification reaction. Esterification. Esterification reaction. Very, very important one. Fruity smell. It has a fruity smell. Esterification reaction. So when acetic acid combines with ethyl alcohol, it gives ester, which is ethyl acetate. Now, two different namings are there. This is ethyl acetate, but you need to know the IUPAC name of this ester. That is, the IUPAC name is ethyl ethanoate. This is the reaction. When acetic acid reacts with alcohol, ethyl alcohol, it gives ester, which is ethyl acetate plus water. This is esterification reaction. Fruity smell of ester is found in this reaction. This is the answer. Most important one. Laboratory preparation of nitric acid. Now, two different reactants are there in case of lab preparation of nitric acid. If it is potassium nitrate or sodium nitrate, you choose one of them to write your answer. Sodium nitrate plus concentrated sulfuric acid. The most important part is the temperature, which is less than 200 degrees Celsius. If it is more than 200 degrees, the reaction is more violent reaction, and the temperature is the most important thing in this kind of questions, where less than 200 degrees the temperature, and we have an acid salt plus like sodium hydrogen sulfate, sodium bisulfate plus, this is the acid salt, plus nitric acid. This one is sodium nitrate, concentrated sulfuric acid, and sodium bisulfate, and nitric acid. This is the lab preparation of nitric acid. Next question. Unsaturated hydrocarbons undergo. We have already discussed this topic. Saturated hydrocarbons, those are alkanes like single bonds. Saturated hydrocarbons undergo substitution reaction, which are alkanes, and unsaturated hydrocarbons undergo addition reaction, alkene and alkyne. So the correct option is unsaturated hydrocarbons undergo addition reaction. Correct option is option 1. The metal hydroxide, which reacts with both acids and alkalis to form salt and water. So the metal hydroxides which reacts with both acids and alkalis to form salt and water, that is amphoteric oxides. Amphoteric oxides reacts with acids and bases like alkalis to form salt and water. So which are amphoteric in nature, amphoteric oxides. Now one of these amphoteric oxides are aluminium hydroxide. Aluminium hydroxide. This is the example of an amphoteric oxide. The correct option is option 3. Next is question number 31. Conversion of ethanol to ethene by the action of concentrated sulfuric acid involves. Conversion of ethanol to ethene by the action of concentrated sulfuric acid. Ethanol to ethene. So ethanol to ethene. This is the conversion of ethanol to ethene. Ethanol to ethene. One important thing is concentrated sulfuric acid, temperature 170 degrees Celsius. What kind of reaction is this? Dehydration, dehydrogenation, dehydrohalogenation, hydrolysis. So this is dehydration reaction. The correct option is 1. Dehydration reaction of ethanol. Dehydration of ethanol. In this reaction, this kind of reaction where dehydration of ethanol is there and the products are ethene. So using concentrated sulfuric acid acts as a dehydrating agent here. This is one of the most important part of organic, that is dehydrating agent. So in this reaction, concentrated sulfuric acid acts as a dehydrating agent and this reaction is a dehydration of ethanol. So the correct option is dehydration, first one. Next, electron affinity is maximum in magnesium, argon, lithium, bromine. So magnesium, argon, noble gas, lithium metal, magnesium metal. So electron affinity left to right, the trend of electron affinity from left to right increases. Now in the among these four options, magnesium, argon, this is not, lithium metal, magnesium metal, bromine non-metal. So metal to non-metal, electron affinity left to right across a period increases. The maximum bromine. Bromine is the correct option. Trends are most important part from periodic table chapter. In the molecule of water, oxygen atom has 1 share pair of electrons, 3 share pair of electrons, 2 lone pairs of electrons, 1 lone pair. First, molecule of water. This is the structure of water molecule where we have 2 lone pairs, 1 lone pair, 2 lone pair. These are lone pairs. One lone pair, 2 lone pairs. So in a water molecule, 2 lone pairs present, 1 and 2. So the correct option is 2 lone pairs of electrons in a water molecule. Correct option is option 3. Next question. Draw the electron dot structure of methane molecule. Electron dot structures, electron dot diagrams are the most important part and the common questions from chemical bonding chapter. So most of the questions are there from electron dot structures, not the orbital structures. Orbital structures are not that important. Just you need to draw the electron dot structures of different molecules from chemical bonding chapter. So methane molecule, methane, one carbon, 4 hydrogen. So carbon has 4 electrons in the outermost shell and hydrogen 1 electron in the outermost shell. This is before combination. The structure electron dot diagram is like this. After combination, structure is this. This is the electron dot diagram of methane molecule. How to combine? This is methane molecule. Methane molecule. Before combination, after combination, this is methane molecule. The electron dot diagram is like this. Nitrogen molecule. Now nitrogen, the electronic configuration is 2 5. So 5 electrons present in the last shell, the outermost shell. The structure is like this: 1 2 3 4 5. Nitrogen molecule, so that is N2. So another nitrogen atom. It also has 5 electrons in the outermost shell, and the structure, the electron dot diagram is this. Please mention the lone pairs in all the different electron dot diagrams of different molecules, and this is the nitrogen. So this is the electron dot diagram of nitrogen molecule and methane molecule. Next question. Which of the following electrolytic cells will silver plating be done on the spoon? From electrolysis, we have two different kinds of part, that is electrolysis using electroplating. So in case of electroplating, 4 different diagrams are there. First one, in this case, silver spoon. So if we have to electroplate any kind of substance, that substance is always placed at a cathode. So cathode, that is a negative terminal. So negative terminal, if this is cathode and this one is anode, then the substance you have to silver plated, or you have to add silver plating, should be placed at cathode, like silver spoon. So in this diagram, here is also silver plate spoon at cathode, here is also cathode, so here is also cathode, and the silver plating, like the silver plate, we need to add at anode. So here silver plate, and at cathode you should add the substance or spoon here. Then there is the another important part, that is the electrolyte. Electrolyte, if you have to add silver, after coated with silver, then the electrolyte should be using any kind of silver solution. So you have to add silver nitrate solution in these two case, but in this two case we have this is distilled water, so this is incorrect. This one is also incorrect. Silver nitrate solution in these two diagrams, but the in Q, here the spoon is placed at the cathode, and in in this one the spoon is placed at anode. So the correct one is this: spoon at cathode and a silver plate is at anode. Then a silver nitrate solution or an electrolyte is there. So the correct option where silver plating is done, the correct option is this, Q. The answer is Q. Answer is Q. This is the correct one. An element belongs to the third period and 16th group. It will have third period 16th group. Third period 16th group, that is third period. So 2, the configuration is 2 8 6. Third period 16 group. Electrons in valence shell, number of electrons 6. Third period, so number of shells 3. Then valence shell, outermost shell, it has 6 electrons. The answer is 6. Draw the structural diagram for the following compounds. 1 propanal, 1 propanal. So propanal, that is aldehyde. So CHO, and the rest are hydrogen. This is the structure of 1 propanal. Then 1,2-dichloroethane. So 1,2-dichloroethane. Here is a chlorine atom. Here is another chlorine atom. Then 1,2-dichloroethane. So this is the structure of 1,2-dichloroethane. Third one is butene structure. So after getting 1,2-dichloroethane, 1,2-dichloroethane. This is the first place of carbon. This one is second place of carbon. One chlorine atom in the first carbon place, and second, with the second carbon we have another chlorine atom. So the structure of 1,2-dichloroethane is this. Third one is butene. So butene, please remember the root word of these organic compounds. If it is bute, pent, or hex, or hep, or methane, ethane, propane, whatever, the root word is bute. So butene, that is bute is the root word. To in is the alkene. So bute to in, bute, number of carbons 4. Bute, then bute to in. So bute to in is this double bond, alkene double bond is there in second number of carbon, that is bute to in, and the rest are hydrogen. So bute, root word, number of carbons 4, then second, at the second place, double bond, and the rest are hydrogen. This is the structure of bute to in. I think the answer is clear to you all. Next question. IUPAC. So in this IUPAC naming, one chlorine atom is here and another one is here. So the group is like no functional group, only chlorine atom. So if this is 1, 2, 3, 4, 5, then root word is pent. Then chlorine at second and third. So 2, 3, chlorine is in this case, and this one chlorine. So 2, 3, 2, 3, dichloro, 2, 3, dichloro. The root word is pent, 5, number of carbons 5. So the root word is pent, 2, 3, dichloro, pentane. All of this are single bond. So alkane, 2, 3, dichloro, pentane. Next structure is this. Please mention the group, or you have to prioritize the group first. Then this one is COOH, that is acid group. Acid group. This is acid group. So oic acid is the term. Now oic acid. Now the root word, number of carbon 1, 2, and 3. Number of carbon 3, mate it prop, propan, oic acid. So the structure is propanoic. The IUPAC naming is propan 1 oic acid, that is propanoic acid. This is the IUPAC name of this structure. Acid group is present. root word, number of carbons 3, so the structure is propanoic. The naming of the structure is propanoic acid. Before going to start this kind of chapters, I need to mention the important functional groups, or the functional groups you need to remember for your organic chemistry chapter. That is, first one is alcohol. This is alcohol group. CHO. CHO, the bonding is like this. Show the bonds like this. Then acid, COOH, that is oic acid. This is all oic acid and ketone, CO. So ketone is this. Then fluorine, chlorine, bromine. The halogens are there. Fluorine, chlorine, bromine. And methyl group, ethyl group. Please mention the groups first. Methyl group, ethyl group, or any other fluoro, chloro, like this. Next question. The fountain starts when so this is the diagram of fountain experiment. This is the fountain, and the fountain starts when a few drops of water from the dropper are introduced into the flask instead of the drops of water. Pooja started the fountain by introducing a few drops of sodium hydroxide to the flask. So this is the dropper. We have to add water to it, and instead of water, the Pooja started the fountain by introducing a drops of sodium hydroxide. So sodium hydroxide is a base. If you use sodium hydroxide here instead of water, then the first question, explain why the litmus solution gets sucked up when sodium hydroxide is used. So if the acid is there, so this is HCl and this one is a litmus solution. If it is a blue litmus solution, then it turns red using this kind of fountain experiment. The color of the fountain is red. But the first question is, instead of water in this dropper, if we use a different like sodium hydroxide, if sodium hydroxide is used, HCl gas is present. So HCl and sodium hydroxide, there is a neutralization reaction. The products are salt and water. So explain the litmus solution gets sucked up. Why the litmus solution gets sucked up? Just because sodium hydroxide is a base. So after using sodium hydroxide instead of water, neutralization reaction happens, and the products are salt and water, neutralized each other. So there is a difference just because of neutralization reaction. Second question, what will be the color of the fountain when sodium hydroxide is used? Justify your answer. So if sodium hydroxide is used, no change in color. Blue color is there. If blue litmus solution is present, then the color is blue. That's because of the neutralization reaction. So the answer is neutralization reaction. Neutralization reaction. Due to neutralization reaction, the neutral products formed. Neutral products formed, which are salt and water. So if sodium hydroxide is used instead of water, then neutralization reaction is there. So no change in color. Third one is, if instead of HCl gas, ammonia gas is filled in the flask and water is introduced from the dropper. Okay, let me clear two important things. If HCl is there in this jar and blue litmus solution present, then the color and also the dropper, water is, we introduce water in the dropper, then the color changes to blue to red. If ammonia gas is present, if ammonia is a basic nature, ammonia basic gas. So if ammonia present, so ammonia is basic in nature. If blue litmus solution is there and we use a dropper and water, so after here instead of HCl gas, according to the question, if ammonia is present, then no change in color. Blue color turns blue. No change. The fountain, the color of the fountain will be in this case is blue. Blue fountain. Ammonia. So no change in color. If it is HCl, then blue to red is the change in color. But if it is ammonia and dropper we use water, then blue, no change in color. No other color is there. The fountain, the color of the fountain is blue only. If blue litmus solution is present. So this is the fountain experiment where you use a jet tube and a dropper and litmus solution is there. Different kinds of gases like basic gas or acidic gas. So HCl is acidic, it turns the blue litmus red. If instead of HCl we use ammonia, which is basic in nature, no change in color. Blue color solution turns blue. The fountain color will be blue. Next question. What property of sulfuric acid is exhibited in each of the following cases? Sulfuric acid is one of the most important chapters, and like different preparation we need sulfuric acid to prepare sulfuric acid itself. In the preparation of HCl gas, when it reacts with sodium chloride, in the preparation of HCl gas, sodium chloride reacts with sulfuric acid. So the question is, what property of sulfuric acid is exhibited in each of the following cases? What property of sulfuric acid in the preparation of HCl? That is the property of non-volatile acid, non-volatile nature. We use sulfuric acid just because of this non-volatile nature of sulfuric acid to prepare HCl. If nitric acid is volatile, we can't use nitric acid to prepare HCl. You have to use sulfuric acid to prepare HCl just because of its non-volatile nature. Next part, when concentrated sulfuric acid reacts with copper to produce sulfur dioxide gas. When concentrated sulfuric acid reacts with copper to produce sulfur dioxide gas, if concentrated sulfuric acid is reacts with copper, produce sulfur dioxide gas, what kind of oxidizing power? Due to its oxidizing nature, oxidizing power, we use sulfuric acid. When copper reacts with sulfuric acid, sulfur dioxide is produced due to its oxidizing power. Oxidized products are formed. These are the oxidized products: copper sulfate, sulfur dioxide, water. These are the oxidized products. Due to oxidizing nature, we use sulfuric acid to produce sulfur dioxide. Next question. So these are the matching column questions. Sodium chloride is has two shared pair of electrons, has high melting and boiling point. So this is ionic bond, electrovalent ionic bond. It has high melting and boiling point, covalent bond, low melting boiling point. So this is option A. Methane, greenhouse gas. Methane is a greenhouse gas. Hydrogen chloride gas is low. It has low melting and boiling points. Hydrogen chloride gas. Then water, it has two shared pair of electrons. Then Zn2 Zn2 plus, Zn2 Zn2 plus, that is oxidation reaction. This is oxidation reaction Zn2 Zn2 plus. Two things are important. Oxidation reaction when electron lose and cations are formed. These are oxidation, and after accepting electrons, that those are reduction reaction. So this is oxidation, this one is oxidation. And water, it has two shared pair of electrons. It has two shared pair of electrons in water molecule, like this. Two shared pair of electrons. A gas cylinder capacity 40 decimeter cube, another numerical type of question, filled with gas X, the mass of which is 20 gram. The mass is 20 gram. When the same cylinder is filled with hydrogen gas at the same temperature and pressure, the mass of hydrogen is 2 gram. Find the relative molecular mass of the gas. So, relative molecular mass is equal to 2 into vapor density. This is the formula of relative molecular mass. If you need to calculate relative molecular mass, you need to add that into product into vapor density. So what is vapor density? Vapor density is volume of a gas divided by volume of a certain gas equal volume of hydrogen gas. So in this question, 40 decimeter cube capacity is filled with the gas X. X is the gas, the mass of which is 20 gram. When the same cylinder is filled with hydrogen gas, the same temperature and pressure, the mass of hydrogen is 2 gram. So the gas X, the mass of that gas is 20 gram. So this is 20. Then this is 2. The vapor density is 10. Now, relative molecular mass is 2 into vapor density. So, we have the vapor density 10. Then 2 into 10 relative molecular mass, that is 20 atomic mass unit. This is the answer. So, no need to change or no need to add or subtract any subtract with in this question. That is 40 decimeter cube. That this is given just to confuse all the students. 40 decimeter cube, not needed here. Next question. With respect to Haber's process. Now Haber's process is the ammonia formation. Temperature of the reaction, temperature in Haber's process 450 to 500. Optimum temperature 450 to 500 optimum temperature. Catalyst use finely divided iron, finely divided iron catalyst, and one promoter is also used, that is molybdenum. Promoter molybdenum is used. Balance equation of the reaction, that is nitrogen, hydrogen, reversible one, this ammonia. 1 volume of nitrogen, 3 volume of hydrogen gives 2 volume of ammonia gas. State one observation in the following cases. So in this kind of questions where state one observation is given, that you have to state the observation and write down the equation for this reaction. Sodium chloride solution is added to a solution of lead nitrate. Okay. Solution of lead nitrate. So this is the solution of lead nitrate. Sodium chloride solution is added. Sodium chloride solution is added. So white precipitate of lead chloride. White precipitate of lead chloride, and another one is sodium nitrate. Sodium nitrate, another product is sodium nitrate. So this is the white precipitate of lead chloride and another product is sodium nitrate. So this is the answer. Now you have to balance this equation. Okay, so this is the observation. That is white. State the observation. So the answer is white precipitate of lead chloride formed. This is the answer. Next, barium chloride solution is added to a solution of zinc sulfate. Zinc sulfate and barium chloride. Again, barium sulfate precipitate, white precipitate of barium sulfate, plus zinc chloride is formed. This is the most important part, that the precipitate formed and the color of the precipitate. The empirical formula of an organic compound is C3H4N. Another stoichiometry question. Its molecular weight is 108. Find the amount of carbon in 1 mole of the compound. Show all the steps involved. Okay. Find the amount of carbon in 1 mole of the compound. The molecular weight, that is 108. Empirical formula weight, that is 3 into 12 plus 4 into 1 plus 14. 36 plus 4 plus 14. 54. So this is the empirical formula weight. Empirical formula weight is 54. This is, if we have the empirical formula of a compound, then we need to, like this, C3H4N into N. So how to find this small n? Small n is equal to molecular weight divided by empirical formula weight. Now molecular weight is given in this question, this is 108, and empirical formula weight, that is 54. So N is equal to 2. Now the molecular formula of this compound is equal to this C3H4N into 2, that is C6H8N2. This is the molecular formula of this compound, C6H8N2. Now the question is, find the amount of carbon in 1 mole of the compound. So the formula of this compound, that is C6H8N2. Find the amount of carbon in 1 mole. In 1 mole, this is C6H8N2. In 1 mole, there is 6 number of carbons, 6 number of carbon atoms in 1 mole. So the amount of carbon, that is 6 into 12. 72 grams. The amount of carbon in 1 mole of the compound. So 1 mole of the compound is this C6H8N2. Number of carbons in 1 mole, that is 6. The amount of carbon 6 into 12, 72 grams. This is the answer. Next question. State giving reasons if zinc and aluminium can be distinguished by heating metal powder with concentrated sodium hydroxide solution. Zinc and aluminium, if it is distinguished or not. Zinc plus concentrated sodium hydroxide, the product is sodium zincate plus hydrogen. If it is aluminium and sodium hydroxide solution, also water is there, sodium aluminate plus hydrogen. You have to balance this equation first. Zinc and aluminum can be distinguished. Zinc and aluminum can't be distinguished. This is sodium, sodium, this is sodium zincate and aluminium reacts with sodium hydroxide. This is sodium aluminate. So in both the cases, sodium salt and hydrogen gas is formed. So we can't distinguish using this reaction. Calcium nitrate and lead nitrate can be distinguished. Yes, calcium nitrate and lead nitrate can be distinguished by using ammonium hydroxide solution. If it is lead nitrate, ammonium hydroxide solution, ammonium hydroxide solution, then lead hydroxide precipitate is formed and ammonium nitrate, another product. This is chalky white precipitate. Chalky white precipitate is formed. But if we react calcium nitrate with ammonium hydroxide, no reaction. If calcium nitrate and ammonium hydroxide reacts, no reaction. If it is excess amount of ammonium hydroxide is present, no reaction. Then also no reaction. Only lead nitrate reacts with ammonium hydroxide to form chalky white precipitate. So we can distinguish using ammonium hydroxide solution, lead nitrate and calcium nitrate. Next question. Draw the electron dot diagram of hydronium ion. Hydronium ion, you have to use the water molecule first. This is the structure of water molecule. Then hydrogen ion. This is hydrogen ion. This is hydrogen ion. And hydronium. So hydronium is this. One lone pair. Another one is hydrogen. This is hydronium ion. Hydronium ion. The structure of hydronium ion is like this. This H3O plus. This is the structure of hydronium ion, electron dot diagram. During electroplating of an article with silver, the electrolyte used silver nitrate, silver cyanide, sodium argentocyanide. Sodium argentocyanide is the correct option. Option C. Next question. State one observation for at the anode when aqueous copper sulfate solution is electrolyzed using copper electrode. We have already discussed this topic in a previous question. That is, if copper electrode in electrolysis, this is anode and cathode, copper sulfate solution is electrolyzed using copper electrode. So copper electrode, this is also copper electrode, cathode, copper, anode is also copper. The reason is, if we use copper at cathode and copper is also used at cathode, and if anode is also copper, the Cu2 plus, this is the discharge, Cu2 plus to Cu, the deposition of copper, the discharge Cu2 plus to Cu. This is cathode reaction. Cathode reaction is this. Now, if we use copper anode, then this discharged Cu2 plus is replaced from this anode like this. This is anode reaction. The Cu2 plus ion discharged at cathode, which is replaced from anode. This is the Cu2 plus. So Cu2 plus is no change, same, remain same, no change in color of the electrode. If we use this copper electrode, both cases, cathode and anode. So the Cu2 plus discharged at cathode, which is replaced from anode. Cu to Cu2 plus, replace Cu2 plus from anode, which is discharged at cathode. So no change in color. The color of the electrolyte solution does not fade at all using copper electrode as copper anode and copper cathode. But if we use platinum at anode, then color fades. Just because no replaceable Cu2 plus is there, no change, so color fades after some time. The main ore used for the extraction of iron, hematite. Hematite is the main ore of iron. Bauxite, aluminium ore. Cryolite is also aluminium ore. Calamine is zinc ore. This is calamine. The main ore is hematite. Heating an ore in a limited supply of air in the absence of air at a temperature just below melting point, that is calcination. Two important parts from metallurgy, calcination and roasting, which is sufficient air, that is calcination. Carbonate ores. Select which is not an alloy of copper. Brass is alloy of copper, bronze alloy of copper, solder not an alloy. This one. Tin and lead. This is tin and lead. Alloy of tin and lead. This is solder. This is the answer. What happens when a glass rod dipped in concentrated HCl acid brought near ammonia gas? Glass rod dipped in concentrated HCl brought near ammonia gas. Then dense white fumes of ammonium chloride is formed. Dense white fumes of ammonium chloride. In this reaction, dense white fumes of ammonium chloride is formed. This is the answer. Write the temperature and the catalyst required during catalytic oxidation of ammonia to nitric acid. Catalytic oxidation of ammonia to nitric acid. So this is the reaction. Catalytic oxidation of ammonia to nitric acid. Sorry, nitric oxide. Catalytic oxidation of ammonia to, this is an exothermic process, exothermic reaction. Nitric oxide. Nitric oxide exothermic reaction, and platinum catalyst. Platinum catalyst is used. The temperature is 700 to 800 degrees Celsius. Exothermic reaction where catalytic oxidation of ammonia and the product is nitric oxide is formed. Then heat plus, this is an exothermic reaction. Catalyst, platinum catalyst is used, and the temperature is also important. That is 700 to 800 degrees Celsius. This is the catalytic oxidation of ammonia. We get this nitric oxide as a product. Then this is the last question. Give balanced chemical equation, the reaction occurring during conversion of nitrogen dioxide to nitric acid. So this is the first step. This is the important Oswald process. Oswald process where we have to make this using the 3 steps to get nitric acid. This is Oswald process. So the first step of Oswald process, after this we have nitric oxide, and nitric oxide to nitrogen dioxide, nitric oxide to nitrogen dioxide. This is the step 2. Then lastly, balanced chemical equation, the reaction during the conversion of nitrogen dioxide to nitric acid. So nitrogen dioxide to nitric acid. Balanced chemical equation. This is the conversion of nitrogen dioxide to nitric acid. This is nitrogen dioxide and this one is nitric acid. This is the conversion of nitrogen dioxide to nitric acid. This is the last question. I think these questions will be helpful for you all, and best of luck for your exam.